The interpretation of the National Electrical Code can vary among different authorities having jurisdiction. It's important to recognize that while an authority having jurisdiction may have allowed the use of flexible wiring methods to connect emergency fixtures, the National Electrical Code specifically states that such use is only permitted where necessary. The intent of this requirement is to prevent the use of flexible wiring methods for convenience or ease of installation. The authority having jurisdiction is responsible for determining whether the use of flexible wiring methods is necessary in a specific application. If there are plans to use flexible wiring methods to connect emergency fixtures, it is advisable to consult with the local authority having jurisdiction to ensure that it is acceptable. They may have specific requirements or interpretations that need to be considered. Here are some additional points to consider. Firstly, the exception in the National Electrical Code that allows the use of flexible wiring methods for emergency fixtures is located in Article 700.12b3. Secondly, commentary aligns with the intent of the National Electrical Code. It is always best to follow the requirements of the National Electrical Code and the local authority having jurisdiction to ensure compliance and safety. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment installation in the United States. It's updated every 3 years, and compliance is essential for ensuring electrical safety. The authority having jurisdiction, or AHJ, is the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure. This can be a local building inspector, a fire marshal, or another designated authority. Emergency systems are crucial for life safety in buildings, providing power for essential functions like lighting, fire alarms, and communication systems during power outages. Article 700 of the NEC covers the installation and requirements for emergency systems. Flexible wiring methods, such as flexible metal conduit or liquid-tight flexible metal conduit, offer flexibility in installation and are often used for connecting equipment that may need to be moved or adjusted. However, the NEC restricts their use in emergency systems to situations where it is necessary, not simply for convenience. NEC Section 700.12b3 specifically addresses wiring methods for emergency systems and provides an exception allowing flexible wiring methods under certain conditions. The key is the word necessary. The NEC emphasizes that flexible wiring methods should only be used when there is a specific need, such as to minimize vibration, allow for equipment movement, or overcome physical constraints. The interpretation of necessary is left to the authority having jurisdiction. They will evaluate the specific circumstances of the installation and determine whether the use of flexible wiring is justified. Factors they might consider include the type of equipment being connected, the potential for movement or vibration, and the overall design of the emergency system. Using flexible wiring methods for emergency systems simply because it is easier or cheaper is not in line with the intent of the NEC. Emergency systems are designed to operate reliably during critical situations, and the wiring methods used must be robust and dependable. Before using flexible wiring methods for emergency fixtures, it is essential to consult with the local authority having jurisdiction. Provide them with details about the proposed installation, including the reasons why flexible wiring is considered necessary. Be prepared to justify your choice and demonstrate that it meets the intent of the NEC. The authority having jurisdiction may have specific requirements or interpretations that you need to be aware of. They may also require documentation or inspections to ensure that the installation complies with the code. Failing to comply with the NEC and the authority having jurisdiction requirements can have serious consequences. It can result in failed inspections, project delays, and potential safety hazards. In the event of an emergency, a non-compliant installation may not function as intended, putting lives at risk. The NEC and the authority having jurisdiction are there to protect public safety. By following their guidelines and working with them to ensure compliance, one can help to create safe and reliable electrical systems. Understanding the NEC requirements for emergency systems and the role of the authority having jurisdiction is crucial for anyone involved in electrical installations. This includes electricians, contractors, engineers, and building owners. By staying informed and working together, one can ensure that emergency systems are installed correctly and operate effectively when they are needed most. Let's delve deeper into the specifics of National Electrical Code Article 700.12b3 concerning wiring methods for emergency systems, particularly focusing on the allowance of flexible wiring. The core principle here is that emergency systems demand the highest level of reliability. These systems are designed to provide power to essential equipment and lighting during power outages, ensuring the safety and well-being of building occupants. Given this critical function, the NEC places stringent requirements on the wiring methods used in emergency systems. Traditionally, rigid metal conduit or electrical metallic tubing are favored for emergency system wiring due to their robustness and protection against physical damage. However, there are situations where the use of flexible wiring methods can be justified, and the NEC recognizes this through the exception in section 700.12b3. This section allows for the use of flexible metal conduit, flexible metallic tubing, or liquid-tight flexible metal conduit in specific scenarios. The key condition is that such flexible wiring is permitted only where necessary. This necessity typically arises in situations where rigid conduit is impractical or impossible to install. For example, when connecting to equipment that is subject to vibration or movement, such as generators or pumps, flexible conduit can help prevent damage to the wiring system. Similarly, in tight spaces or where there are numerous obstructions, flexible conduit can provide a more practical solution for routing wires. It is crucial to understand that the allowance for flexible wiring is not a blanket permission. It is not intended to be used simply for convenience or to save time or money on installation. The NEC emphasizes that the decision to use flexible wiring must be based on a genuine need, not on personal preference or ease of installation. The authority having jurisdiction plays a critical role in determining whether the use of flexible wiring is truly necessary. The authority having jurisdiction will review the proposed installation and consider the specific circumstances to decide whether flexible wiring is justified. Factors that the authority having jurisdiction might consider include the type of equipment being connected, the potential for movement or vibration, the complexity of the wiring route, and the overall design of the emergency system. To gain approval for using flexible wiring, it is essential to provide the authority having jurisdiction with clear and convincing evidence of the necessity. This might involve submitting detailed drawings, specifications, or calculations that demonstrate why rigid conduit is not feasible. It is also important to be prepared to answer questions and address any concerns that the authority having jurisdiction may have. The NEC also imposes specific requirements on the installation of flexible wiring in emergency systems. These requirements are designed to ensure that the flexible wiring is installed safely and reliably. Firstly, the flexible conduit must be properly supported and secured to prevent it from sagging or being damaged. Secondly, fittings used to connect the flexible conduit to equipment and junction boxes must be approved for the specific type of conduit being used. Thirdly, the length of the flexible conduit should be kept to a minimum to reduce voltage drop and improve system performance. Finally, the flexible conduit must be properly grounded to provide a safe path for fault current. It is also worth noting that some local jurisdictions may have additional requirements or restrictions on the use of flexible wiring in emergency systems. It is essential to check with the local authority having jurisdiction to determine if there are any specific rules or regulations that apply in a given area. Ignoring these requirements can result in failed inspections, project delays, and potential safety hazards. In addition to the NEC requirements, it is important to follow industry best practices when installing flexible wiring in emergency systems. This includes using high-quality materials, properly training installers, and thoroughly testing the installation after completion. By adhering to these best practices, it is possible to ensure that the emergency system will function reliably when it is needed most. In summary, NEC Article 700.12b3 allows for the use of flexible wiring methods in emergency systems only when necessary. The authority having jurisdiction plays a critical role in determining whether the use of flexible wiring is justified. It is essential to provide the authority having jurisdiction with clear and convincing evidence of the necessity and to comply with all applicable NEC requirements and local regulations. By following these guidelines, it is possible to safely and reliably use flexible wiring in emergency systems when it is appropriate. This topic warrants exploring the different types of flexible wiring methods permitted by the NEC and their specific applications in emergency systems. The NEC recognizes several types of flexible wiring methods, each with its own characteristics and suitability for different applications. These include flexible metal conduit, or FMC, flexible metallic tubing, or FMT, and liquid-type flexible metal conduit, or LFMC. Flexible metal conduit is a racewave circular cross-section made of helically formed interlocked metal strip. It is commonly used for connecting lighting fixtures, motors, and other equipment where flexibility is needed. FMC is relatively lightweight and easy to install, but it is not liquid-tight and offers limited protection against physical damage. Flexible metallic tubing is similar to FMC, but it is typically smaller in diameter and has a thinner wall. FMT is often used for connecting recessed lighting fixtures and other low-voltage equipment. It is even more flexible than FMC, but it offers even less protection against physical damage. Liquid-tight flexible metal conduit is a flexible metal conduit covered by a liquid-tight, non-metallic jacket. It is used in wet locations or where protection against corrosive substances is needed. LFMC provides good protection against moisture and physical damage, making it a popular choice for outdoor applications and industrial environments. When selecting a flexible wiring method for an emergency system, it is important to consider the specific requirements of the application. Factors to consider include the location of the equipment, the potential for exposure to moisture or corrosive substances, and the need for protection against physical damage. In dry, indoor locations where there is little risk of physical damage, FMC or FMT may be suitable. However, in wet locations or where there is a risk of exposure to corrosive substances, LFMC is the preferred choice. In areas where there is a high risk of physical damage, rigid conduit may be necessary, even if it means sacrificing some flexibility. The NEC also imposes restrictions on the length of flexible conduit runs. In general, the length of flexible conduit should be kept to a minimum to reduce voltage drop and improve system performance. The NEC does not specify maximum length for flexible conduit runs, but it does require that the voltage drop in the circuit does not exceed 3%. Voltage drop can be calculated using various formulas and online calculators. It is important to consider the length of the conduit run, the size of the conductors, and the current flowing through the circuit. Another important consideration when using flexible wiring in emergency systems is grounding. The NEC requires that all metal raceways, including flexible conduit, be properly grounded to provide a safe path for fault currents. Grounding can be achieved by connecting the conduit to a grounding electrode conductor or by using a grounding bushing. It is important to ensure that the grounding connection is secure and that it is properly sized to carry the expected fault current. In addition to grounding, it is also important to protect flexible conduit from physical damage. Flexible conduit is more vulnerable to damage than rigid conduit, so it is important to take steps to protect it from impact, abrasion, and other hazards. This can be achieved by using straps, clamps, or other supports to secure the conduit to the building structure. It is also important to avoid running flexible conduit in areas where it is likely to be stepped on or run over by equipment. When installing flexible wiring in emergency systems, it is essential to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation techniques, including the correct way to terminate the conduit, support it, and ground it. Following the manufacturer's instructions will help to ensure that the installation is safe and reliable. Finally, it is important to remember that the use of flexible wiring in emergency systems is subject to the approval of the authority having jurisdiction. The authority having jurisdiction will review the proposed installation and consider the specific circumstances to determine whether the use of flexible wiring is justified. It is essential to provide the authority having jurisdiction with all the necessary information and to be prepared to answer any questions that they may have. By understanding the different types of flexible wiring methods, the NEC requirements, and the importance of working with the authority having jurisdiction, it is possible to safely and reliably use flexible wiring in emergency systems when it is appropriate. Now we need to talk about common mistakes to avoid when using flexible wiring in emergency systems. One common mistake is using flexible wiring when it is not truly necessary. As mentioned earlier, the NEC restricts the use of flexible wiring in emergency systems to situations where it is essential. Using flexible wiring simply for convenience or to save time or money is a violation of the code. Another common mistake is using the wrong type of flexible wiring for the application. As discussed above, there are several types of flexible wiring, each with its own characteristics and suitability for different applications. Using the wrong type of flexible wiring can compromise the safety and reliability of the emergency system. For example, using FMC in a wet location can lead to corrosion and electrical failures. Another mistake is failing to properly support and secure the flexible conduit. Flexible conduit is more vulnerable to damage than rigid conduit, so it is important to properly support it to prevent it from sagging or being damaged. The NEC requires that flexible conduit be supported at intervals not exceeding 4.5 feet and within 12 inches of boxes, cabinets, and fittings. Another mistake is using improper fittings to connect the flexible conduit. The fittings used to connect flexible conduit must be approved for the specific type of conduit being used. Using improper fittings can result in loose connections, which can lead to electrical arcing and fires. It is also important to ensure that the fittings are properly tightened to provide a secure connection. Another mistake is exceeding the maximum length of flexible conduit runs. As mentioned earlier, the NEC does not specify a maximum length for flexible conduit runs, but it does require that the voltage drop in the circuit does not exceed 3%. Exceeding the maximum length can result in excessive voltage drop, which can cause equipment to malfunction. Another mistake is failing to properly ground the flexible conduit. The NEC requires that all metal raceways, including flexible conduit, be properly grounded to provide a safe path for fault currents. Failing to properly ground the conduit can create a shock hazard. Another mistake is neglecting to protect the flexible conduit from physical damage. Flexible conduit is more vulnerable to damage than rigid conduit, so it is important to take steps to protect it from impact, abrasion, and other hazards. This can be achieved by using straps, clamps, or other supports to secure the conduit to the building structure. It is also important to avoid running flexible conduit in areas where it is likely to be stepped on or run over by equipment. Another mistake is failing to follow the manufacturer's instructions. The manufacturer's instructions provide detailed information on the proper installation techniques, including the correct way to terminate the conduit, support it, and ground it. Failing to follow the manufacturer's instructions can compromise the safety and reliability of the installation. Another mistake is neglecting to consult with the authority having jurisdiction. The authority having jurisdiction has the final say on whether the use of flexible wiring is permitted in a given application. Failing to consult with the authority having jurisdiction can result in failed inspections and project delays. By avoiding these common mistakes, it is possible to ensure that flexible wiring is used safely and reliably in emergency systems. A thorough understanding of the NEC requirements, proper installation techniques, and consultation with the authority having jurisdiction are essential for success. It's also worth noting the importance of proper documentation when using flexible wiring in emergency systems. Maintain detailed records of the installation, including the type of flexible conduit used, the location of the conduit runs, the reasons why flexible wiring was necessary, and any approvals obtained from the authority having jurisdiction. This documentation can be helpful in the event of future inspections or maintenance work. Furthermore, ensure that all personnel involved in the installation are properly trained and qualified. Working with electricity can be dangerous, and it is essential that all workers are knowledgeable about the NEC requirements, proper installation techniques, and safety procedures. Regular training and continuing education can help to keep workers up to date on the latest codes and best practices. Finally, it is important to remember that electrical safety is everyone's responsibility. By following the NEC requirements, using proper installation techniques, and working with qualified professionals, it is possible to create safe and reliable electrical systems that protect people and property. Let's discuss some real-world examples of situations where flexible wiring might be deemed necessary in emergency systems. One common example is connecting emergency generators. Emergency generators often have vibration dampening mounts to reduce noise and vibration. Using rigid conduit to connect to a vibrating generator can transmit the vibration to the conduit system and the building structure. This can cause damage to the conduit, the generator, and the building. Flexible conduit can absorb the vibration and prevent it from being transmitted. Another example is connecting emergency lighting fixtures in suspended ceilings. Suspended ceilings are often used in commercial buildings to conceal wiring and ductwork. The ceiling tiles are supported by a grid of metal runners. It can be difficult to run rigid conduit through the ceiling grid, especially in tight spaces. Flexible conduit can be easily routed through the ceiling grid and connected to the lighting fixtures. Another example is connecting equipment that is subject to movement or adjustment. For example, emergency power transfer switches may need to be moved or adjusted during maintenance. Flexible conduit can allow for this movement without damaging the wiring system. Another example is connecting equipment in hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. In these locations, it is important to use explosion-proof wiring methods to prevent electrical arcs from igniting the flammable substances. Explosion-proof flexible conduit is available for use in hazardous locations. These are just a few examples of situations where flexible wiring might be deemed necessary in emergency systems. The specific circumstances of each installation will determine whether flexible wiring is appropriate. It is important to consult with the authority having jurisdiction to determine whether flexible wiring is permitted in a given application. It is also important to document the reasons why flexible wiring was necessary and to obtain approval from the authority having jurisdiction before proceeding with the installation. In addition to these examples, there may be other situations where flexible wiring is necessary due to physical constraints or other factors. The key is to carefully consider the specific requirements of the application and to consult with the authority having jurisdiction to ensure that the installation complies with the NEC and all other applicable codes and regulations. Thinking about scenarios where flexible wiring might not be considered necessary, consider a large, open room with unobstructed access to the emergency lighting fixtures. In this case, there may be no compelling reason to use flexible conduit. Rigid conduit can be easily installed and will provide superior protection against physical damage. Another scenario is a data center with a dedicated emergency power system. In this case, the emergency power system is critical for maintaining the operation of the data center. The wiring system must be highly reliable and resistant to failure. Rigid conduit is the preferred choice for this type of application. Another scenario is a hospital operating room. Operating rooms are critical care areas where electrical safety is paramount. The wiring system must be designed to minimize the risk of electrical shock. Rigid conduit is the preferred choice for this type of application. These are just a few examples of situations where flexible wiring might not be considered necessary. The specific circumstances of each installation will determine whether flexible wiring is appropriate. It is important to carefully consider the requirements of the application and to consult with the authority having jurisdiction to ensure that the installation complies with the NEC and all other applicable codes and regulations.